Welcome back, everybody. As a quick reminder, I'm your host today, Gary Kevorkian with the Cisco Emerging Technologies and Incubations Group. Going to get started on our first session in our middle portion of ScaleX today. We have our industry panel, Security at Civilization Scale. I'm going to turn it over to Ed Warnicke, who is our panel lead, to let him do a quick introduction of the session and his co-presenters. Thanks, Ed.
Excellent. So when people talk about security, they're usually talking about how do they secure something within a particular organization, generally speaking. There's not a lot of thought given to the larger scale issues around security. For many people, large scale means their entire company or organization, possibly a small number of partners. The parts in general, in terms of partnership with other organizations, are often slow moving. But as we're increasingly seeing the world balkanize into smaller and smaller microservices, and the software as a service model follow that in terms of being able to pass off different pieces of function to various parties, you start having to think about what security really looks like when you have to secure things where there are hundreds of thousands or millions of potential participants, and the participants involved come and go very quickly. And this starts to look at how you actually want to secure things at the scale of your entire civilization. So joining me today, we have a number of panelists. Typically speaking, I find it much more interesting to see what the panelists have to say about themselves by way of introduction. So we'll just sort of wander through our list of distinguished panelists and see how they choose to describe themselves. So I'll just wander down the list of the grid. Shall we start with Eli?
Sure. Hi, everyone. My name is Eli Nesterov. I work at company ByteDance as a security engineering manager and building zero trust infrastructure for the whole company. For those who are not very familiar with the company named ByteDance, I can say that this is a company behind a well-known application, TikTok. And before joining ByteDance and doing this zero trust architecture, I've been helping improve security for companies like a Facebook, or trying to build things to fight automation and bots that shape security, and improving web application security at F5 networks before.
Excellent. Thank you, Eli. Frederick, you're up.
Sure. So there's a couple areas that I work on. So the first is I do stuff in the networking space. I'm one of the co-founders of Network Service Mesh, which is a CNCF project. Ed should be very familiar with that. And through that, I've gotten involved with a variety of different areas. So one of the things I'm focusing on is how do we do zero trust with the next generation infrastructure of networking infrastructure that's coming along. And the next generation infrastructure has a lot of large and small things all cooperating, blurred lines. You don't necessarily own all of the equipment or all of the devices that you're communicating with, and the edge. As we start to push towards edge, we start to see things run very close to you. So this starts to become a very blurred area. And we also, one of the other areas I focus on is also applying these exact same type of technologies and applying them also to the healthcare industry, which is what my company is focusing on, doc.ai. So we're focusing on privacy preserving technologies, and an important part of preserving privacy is you have to be able to preserve security as well. And again, at the edge, how do we not collect information but still be able to operate it? And while that information is in transit, do our best to help others maintain their security and privacy. So two particular areas that I'm fortunate enough to be able to spend my time focusing on.
Excellent. So next up, Mark.
All was. Okay. Hi, everybody. My name is Mark Burgess. I was a professor at the University of Oslo in computer science. My background is in physics, theoretical physics. Some of you may know me from such movies as CF Engine for Home Improvements. And since leaving the CF Engine company, I've been an independent consultant working with all kinds of folks on all kinds of things. I do stuff with things.
Yeah, CF Engines for Home Improvement is definitely one of the reasons I let panelists introduce themselves. Excellent. I didn't realize your background was theoretical physics minus string theory. We should chat later.
Okay.
So next up, Sergio.
Hey, everybody. I am a senior solutions engineer working on the CTO office of the Networking and Security Business Unit. And I am working in different projects. One is Tanzu Service Mesh, which is a service mesh that spans users and data in addition to services. And I'm also part of another project, which is basically part of a Zero Trust framework.
Excellent. And then finally, Casey.
Hi there. Sorry, I'm struggling with my video a little bit, but I'll get it before the end.
Excellent.
I'm not in industry. I'm an academic, but I've been working on measurement-informed, empirically grounded approaches to security at a global scale. So I'm really honored and excited to be listening to you folks talk, and maybe I'll have something to contribute to.
No, I imagine you've been on the cutting end of the civilizational scale, but a little bit more than some of the rest of us. So, excellent. So the topic for this panel is sort of intentionally somewhat amorphous. It's one of those things where you take a bunch of bright people and you shake them and you see what falls out. And so I'm going to start with sort of a fairly amorphous question, which is, so when you think about security at civilizational scale, what are the things that come to mind for all of you? Because it could mean all kinds of things, and there are many aspects to the problem that may come up.
I can start with my thoughts. So when I thought about it, it's kind of interesting question, and I'm glad it kind of resonates a little bit with what Frederick been saying about, but in spite of recent events with macOS and new Apple and OCSP, I guess what's appear interesting for me is the security and the privacy always come along hand in hand with all this events. So we're trying to build security system, and Apple has a pretty good intent to secure software that's running on your laptops, but there is always kind of little flaws in designs that's other part of the system trying to game. And I think what's important when we designing the perfectly secure systems at scale, we tend to forget about privacy. And that's actually interesting question about like designing all this stuff. Should we design the perfect secure systems that would sacrifice some privacy, or we shouldn't? Any thoughts, Frederick, on that?
Yeah, one of the things I did recently was I actually looked up the definition of security and privacy, and the security is freedom from danger, and privacy is freedom from observation or certain types of intrusion. And I think part of it is the two of them are two separate things. And one of the big things that we have to look at is like we see this with new technologies that are coming along. It's not just about the network. It's not just about things like what's your privacy in Facebook or what's your security when it comes to your bank. It's also what do we do with new technologies that are coming on that demand large quantities of data, like training up AI. And there's a security aspect. How do we secure the models, or how do we secure the infrastructure that they run on, or the devices that they run on, including the user's device? how do we make sure users can have secure devices? But there's also the privacy portion, which is how do I make sure the data itself remains private while I'm operating on it? And there's new techniques that are coming up that are helping with this. You have things like federated learning, which leaves the data where it's at. You can then train on users' devices, or you can collaborate with other companies without having to share the actual data. But it's actually not enough. You need to bring in other techniques, because you can actually take a model, inspect it, look at where the maximums and minimums are in the model, and then work out who was in the training set and properties about them. And so you then have to apply things like differential privacy or other similar techniques into these systems. And these are not readily apparent at times. It takes, in some scenarios, where we may be missing things that have severe impact, and it takes a little bit of time to work out exactly how do we make sure that we discover where these holes or gaps are, both in security and privacy. And we have to maintain privacy, because if we don't, we're not going to gain the trust of the civilization at large. And so any security measures that we put in is going to be met with resistance. And we can see that playing out in a large stage right now with things like COVID-19, where people are not trusting authority. And because they're not trusting authority, when they say something like put a mask on or something similar, people are saying, I'm not going to do that because I don't trust you, the authority. And so we have to take a real hard look at why people don't trust it. And there could be very good reasons why that trust is not there. And I think one of the keys to solving that is to not just say, hey, we're preserving your privacy, but actually do it and show them mathematically, give them the information so they can reason about it.
So maybe I can jump in here. I think Frederick makes a really good point that trust, of course, is the basis of security. And if we take it up a notch to ask the question of what vulnerabilities are there about a civilization, the civilization scale that we're trying to protect from in the sense of security, we've got to ask, what are the functions of civilization? And in the one sense, you can say, somehow the internet short circuits civilization to your local domain by this very short path and makes it very easy for us to communicate. But on the more traditional level, the function of a civilization, of course, was to give us our exit strategy from hunter-gathering, to actually come together so we don't have to be individuals anymore. We work together in groups and teams and collectives of different scales, from towns, cities, countries, and so on, which are a bunch of sort of virtual or semi-virtual boundaries with associated politics in between. And the degree to which people, things, devices are able to cooperate and come together to work on a new level as an entity, so to speak, depends a bit on the politics of each individual group. So there's that sort of political aspect to the boundary management in a civilization. The purpose of civilization is to bring us together so we don't have to be alone. We can delegate tasks. And of course, the infrastructure that provides for that often then becomes the vulnerabilities of that society, because we come to depend on those things which become invisible to us. So, the traditional things are clean water, shelter, power, the famous saying that we're never more than 3 meals away from anarchy is pretty, if you look around the world today, the kind of protests and whatnot that we've seen the world in the last couple of years, we've seen civilization on the brink around the world in different ways for want of financial networks, communications networks, monetary networks, and all of these different networks. So networks play an important role, but there are all kinds of vulnerabilities, and they're all pretty much infrastructural vulnerabilities in my sort of broad view.
I think I can chime in. There are additional topics which sit on top of the infrastructure as well. So if we think about civilization scale, we also have to think about that things are no longer static, right? So users are moving all the way around, and maybe the same person does not have or should not have the same access to the same pieces of data, depending on not only what the level of risk is, attending to things like, if an asset is vulnerable or not, or what kind of vulnerability does it have, but also regarding who the user is, right? And who the user is means that the identity of the user is now a complex and dynamic construct, right? So the identity can be composed of different things for that user, different attributes, like, for example, the records of the user, so who the user is, and but it can also have more dynamic attributes, like, for example, what's the reputation of that user in terms of previous transactions of the user, or where the user is located, or where was the user located. And looking at the other end of the spectrum, so if we think about a services and data, and there are also vulnerabilities that happen at service level, right? Software is no longer created. It is a big chunk of software is composed, right? So we create something, but we reuse components that are out there. And those components might have vulnerabilities as well.
Sergio, to slightly piggyback on your point about vulnerabilities, I think the interesting question in this is like, okay, we have vulnerabilities in hardware, in software, everywhere. Where is the trust, and like whose responsibility on fixing them, right? Because between user or between devices that I have at home to up to the cloud, there is a huge stack of protocols and things that's talking to each other. And there is a telco in between, and there is a bunch of providers in between, including cloud providers. So where's the probably when I hear Casey points on this, so it's like where's the responsibilities and where is the trust? Should be like, because there's like so much implicit trust between like things communicating to each other over internet, right? And what's your thoughts about this?
You're muted, Casey.
This is fascinating listening. Yeah, I'm always amazed that, frankly, it works at all because you have not only, and I really like Sergio's point about we're not just building systems from scratch, we're composing systems. Well, the internet architecture was designed to be all about composing, right? I mean, you have the hourglass, you have the narrow waist in the middle, which was the IP layer, and that was intentionally put in place to be, the central point, such that you could have a lot of innovation, disruptive innovation on top of it at the application layer, and even disruptive innovation underneath it at the physical layer. Like, it doesn't matter what goes on above and below. And in fact, we want to incentivize as much innovation as we can in that space, as long as it interoperates at the IP layer. The cost of that, the trade-off, is that it turns out to be really hard to innovate at that IP layer. And given that IP layer and the layers, let's say immediately around it, but we call them the infrastructure layers. So it's IP and BGP, DNS, sort of the things that make your packets go from one place to the other safely in a trustworthy manner. At least that's what we hope. But it turns out there's lots of sort of built-in vulnerabilities at those layers that are there mostly for historical reasons, because they weren't quite building the global internet. That's not what they thought they were building at the time. So the trust and the threat models were somewhat different. And then once the community, the IETF, realized that, oh, okay, this thing is going to pretty much replace every other communication substrate that we've ever used, they spent many years trying to retrofit security back into these layers. And the focus was on technical solutions for retrofitting security, like BGP-SEC, SBGP, DNS-SEC. And all of these solutions have hit, really, I like the theme of this panel, because they've hit what happens when you try to do this at a civilization scale, where the problems that you encounter are not going to be technical problems. They're going to be problems of political, economy, and culture, and society, and even governments that don't always have the same incentives about what solution to deploy or what security goals are. So now we are 30 years into those attempts to retrofit technical solutions back into the plumbing of the infrastructure, the platform on which we build everything else. And we're kind of hitting a wall. We're kind of realizing, okay, maybe this isn't going to work. We're going to have to go back and rethink, what does it mean to have security at civilization or even just super company scale? And I believe we're going to be trying different. In fact, I'm working on proposals to try different approaches that will include understanding and measurement of what the structure of the network looks like now, and sort of maintaining that a level of transparency, at least to people who are willing to orchestrate their own behavior to stay within a set of codes of conduct that are associated with better security. I think the solution to a lot of these, again, not within a company, but when you start connecting companies together, which is what the internet is all about, you're going to have to appreciate the need for non-technical approaches to the problem. Some agreement among players that, okay, we can't get all of this out of technical protocols. It's going to have to be other kinds of protocols that help us with security. Does that help?
No, that helps tremendously. And it sort of brings around, having spent my whole career in networking, sort of a central frustration, which I think you would immediately recognize, which is the problem is not people saying no. The problem is people failing to say yes. And so you can do all kinds of things to try and innovate at that IP layer, but the number of people who have to actually agree and say yes is so large, and the ability to coordinate that many people, even just against inertia and disinterest, is so difficult that it becomes a very challenging problem. And it sort of harkens a little bit back to sort of even a super level above the conversation we had about trust earlier, where it's not so much even about those folks not trusting each other, it's literally about the incentives and the interests aligning.
It's interesting that, the custodians of the internet have been, pardon me, excuse me, the custodians of the internet have typically been techie folks like us, right? Who believed, as Casey said, that the solutions to the problem were of a technical nature. Could they stick a bit of security on the edge of DNS or BGP, squeeze a bit of that secure paste into it and make it all good? But turns out that many of the issues are of a political nature, and the kind of people in tech that we deal with are not people who even want to think about those kind of issues. And then when people are forced at a more societal level to consider certain issues like this in politics and in interest groups and whatnot, they often let the politics override, right? And then they weaponize the issues to create conflicts on a different level. So there's really a kind of a mismatch between the technological level and the political level in this kind of boundary management issue, and at what level the protocols are still streaming. Thank goodness we could, we can still cut them off from the bottom up. We can pull the plug, right, to stop them from talking, but that may not be a good thing.
And what you're saying is a form of delegation. People often think of delegation as like the boss or the leader handing down edicts or similar, but the opposite is true as well. It's like we, as a society, delegate champions to go try to tackle some of these issues, and we don't always support them to the degree necessary so they can solve them, which is not always a bad thing, especially when you look at dictatorships and similar. But in this particular scenario, like one of the things I think we're missing in our technology is a way to model some of these types of concerns. Like it's very rare when I come across something that actually models suspicion. People have worked it in a various haphazard way, but when you bring a new device into your network, or you connect to a new device, and you develop a set of suspicion around it automatically, like where does it come from? Does it come from a trusted vendor? Is it something I brought in? Is it something that some random person brought in? If so, is it someone that it's like you start running through these set of scenarios, and we don't model these things well in our infrastructure. And when we drive towards zero trust, and we start to integrate all these various systems together, that suspicion, I think, is going to that modeling of suspicion, I think, is going to be incredibly important, because when you have someone log in, you may say, "Oh, you logged in to play a video game. Okay, your phone-based two-factor authentication with an SMS message was more than enough. You have somebody logging in to make a large financial transaction for a company, you may actually want cryptographically secured multi-factor authentication across multiple people in order to say, yes, this thing was approved. And so you end up with these various levels of suspicion. And the same thing goes within things like networking. Like this BGP system is making a claim that I need to route information on towards this direction. It's like the initial default was, yes, I trust everyone because you knew how to format a message to me. And so I'm going to accept your message. And we need to move away from that type of world to a more a less clear cut and with varying degrees of capability based upon the level of suspicion that is there.
I find this issue extremely fascinating because we're so inconsistent in the way that we assess threats to ourselves and vulnerabilities and privacy, the need for privacy. In the West, we are totally happy walking out in broad daylight, being seen by everyone, slapping people on the hand as we go past, and yet we're terrified of being caught on a camera, which is there to protect us by the police or something like that. Whereas you find in countries where people literally cover themselves completely when they go outside because they're terrified of being seen on the street, they are often extremely happy to be seen on camera because they feel safer because somebody's looking after them and watching them. And these attitudes are, all over the shop and almost impossible to predict in any sort of rational way.
Yeah, and
it's almost like humans are.
You first, Ed.
It's almost like humans are part of the engineering domain or something.
Yeah, and this also shows a different set of values. Like that's why it has to be a model, but the model can't be rigid. It has to be set up so I can decide what's important to me. You can decide what's important to you, and if we can find a nice middle ground where we can trust each other enough, and then we communicate.
Yeah, but for most of people, and that's to kind of contradict Mark's point. The internet and lots of things built by techie people for techie people, and what users and customers want is just like one big button, make it easy. Like I brought a new device, I wanted to connect and work somehow, and I'll worry about privacy when someone will steal my data, like a phone number, and start doing robocalls to me, or I'll get a bunch of spam. Yeah, and privacy is a pretty interesting question there because it's very, very different for different people in a different time. And like, where's everyone's thoughts on the role of government in all these worlds, right? Because it seems like internet and everything being built like a kind of startup, and at this point we have like 1 billion people using these technologies, but we all now understand that something needs to be changed. So like it seems to be there's should or shouldn't be some regulation, like for example FTC doing some regulation to vendors, right, saying like, hey, your devices or your software has too many vulnerabilities, so we might just do not allow you to sell it until you improves this situation. So what's the role of government in all this?
So I mean, part of it is how fast things move. I don't know how many folks here have ever looked at an RFP that had a government regulation that requires you to do something that was substantially less secure than best practice, because that was the requirement. And the requirement was written when that was the best practice, but the requirement is never going to change. And so you are literally required to make your system less secure to comply with government regulation.
Yeah, and this actually is really important because when you start looking in the telecom space, many countries have policy, governmental laws that say you must implement to a standard. And those standards, if you're pitching something that's not in a standard, then they may not be able to accept what you're taking. So you end up with this chicken and egg problem. So, but part of what happens, the way people have tried to get around some of this, and there's other political and vendor games that run into this. But like if you look at something like Etsy, they wrote significant portions of Etsy, and significant portions of it had never actually were implemented because it turned out that for a variety of reasons to be unfeasible or uneconomical or so on to do so. And I think part of the reason why is because some of the government said we need a regulation or a standard in order to implement this before we will accept it. So portions of it were written in anticipation that some of these things may be built. And you compare that to something like the IETF, where you cannot standardize something in the IETF unless you have a working implementation of it and can demonstrate that it works. And so this particular area is relatively complex, and you end up with building a minimum level to play at, because you have to be able to hire people for very long periods of time to actually get the standards in. Even if you're not playing in the regulation part, you still have to play in the standards part at that point. And those standards can be very difficult to jump over. And a really good example was some of the regulations that have been put in for privacy that may end up entrenching Facebook, because the barrier for entry is now so high that it makes it unfeasible for a new entry to come in and challenge Facebook. And I don't know whether that'll be true or not in the long run, but it's certainly something that some people have flagged. And so so every action that we take has a series of interactions that can be difficult to predict, and we have to using the various forms of observability, such as what Casey had mentioned before. We have to make sure we have these things in place so we can try to work out what those effects are, but also while balancing privacy as well in the process. So it's going to be a difficult area to balance properly, but we do have to give it our best shot.
Yeah, I think another area when we talk about security and privacy is like basically usability, right? Which we also often tend to forget, especially when it comes to end users. But it's not actually always to end users. It's also like building systems for developers, for example, right? From user perspective, user wants just like one button, make it work and make it secure, probably. Like if someone thinks about secure, but from building systems for developers, right? Like zero trust infrastructure, I think that's like, let's say we're building in for developers. Like what I want is like the developers to not think about like how they need to two services talk to each other, how they authenticate, and how they get MTLS between them, right? So that's my ideal situation and ideal goals. It's like developers do not think about it at all.
So if you make your system sufficiently unusable, they will be insecure. So I'm second generation software. I'm a coder like my father before me. And back in the 70s, he found himself working for a municipal government. And among other things, they were just installing computing systems for their police to file their reports. And they had very strict requirements about long and highly complicated passwords for the police to log into the terminals. The result of which was that if you walked into any police station in the city, you would find dozens of sticky notes attached to every terminal with the username and password of the officer, so that when the officer walked up, they could go and see what their password was and log in. But of course, the result was anyone with physical access to the terminal could log in as any officer in the precinct. And so if you don't think about the usability of your security, you will intrinsically become massively insecure.
Yeah, although I don't think I've seen a sticky note hacked yet. So I think there may be some other benefits there. But yeah, and I think that's actually a hugely important part. Like it's actually the thing that is actually selling Apple software and hardware. It's like secure out of the box and safe and privacy preserving out of the box. And that's for your average user. They don't want to have to they don't want to have to think about that. In fact, we don't want them to think about it. Do do we want our doctor trying to mess with security and privacy issues in the software we build for them while they're in the middle of trying to prep a life-saving surgery? Like, we want these things to be as easy to work as possible so that they can focus on getting their job done. Because at the end of the day, like, it's not technology for the sake of technology. It's technology for the sake of bettering bettering people and their capability to perform their jobs or for quality of life.
Yeah, I like that you brought this point, because I think what we do exactly with all this cloud infrastructure and service mesh and Kubernetes is making things more complicated than before, especially on network layer, how to make two things talk to each other, right? Because before, like, if you think about like Kubernetes and networking and running it in a public cloud, if you do it everything from scratch, you need to, like, you basically need to know the whole stack from layer 2 up to layer 7, and in a way that's, I think, like 10 or 15 years, you probably had a few people working on to make everything working, right? So you need to know how BGP work, you need to know how to IP work, MTLS, etc., right? And before you had like special people doing like certification and basically configuring all this stuff. And I kind of feel sometimes we're making things easier to scale. Like, let's say Kubernetes, you can easily scale applications running, but it makes it insanely complex system to maintain and manage, which not making it easier for adopters or like for scale adopters.
I would disagree with that in terms of the, what things have Kubernetes and service mesh made easier or more complicated. So we also have to think about that maybe service mesh is a technology that is not yet fully developed, right? And maybe it is a term that we are also abusing, like we have been abusing in the past about other terms like SDN, right? So if we think about SDN, it was, so it existed already. So if we think about sidecars and all these things about the service mesh, maybe that's one way of think about the service mesh, but there are other ways as well, right? So the service mesh is no more than services interconnected, where, in some way the network is the application and the services that compose this application, right? So when we scale that model, so when we are, part of an application team and we know the whole stack, then we can do whatever we want. We're in full control. The problem is when we try to scale that model, right? So we have multiple applications built by multiple different teams in different companies, maybe that do not trust each other, that they have to communicate in some way. So how do we scale this model? So one problem is from the technology perspective, right? So it is, if what I am using to build my service mesh, it is all of the services that at an application level, the microservices that compose the application are going to need, like a service discovery, like MTLS, like a identity provider, etc. And I try to normalize these, or to try to set a standard across all these other applications and developers who have decided to use a different technology stack. That's a huge problem, right? That's exactly the problem that these service meshes were thought to solve, right? So how do we do this at a scale? Because microservices had a lot of promises, like freedom to use technologies, freedom to use programming languages, freedom to use technology stacks, and that is very nice at a small scale, right? And we were rushing to get out of silos and making long-term commitments to technology stacks. The reality has been different, right? So the moment that one of those application teams tries to scale, it's a problem, right? It's not that. So these application teams are also self-sufficient. So we have many of them now. So each of them has freedom because that is what they wanted, and now they have an interoperation problem, right? So it has not been, so all the promises of microservices, although they have been fulfilled for some things, they made things much more complicated for others, right? And
yeah, I actually really like this point, and it brings me back to what I was saying in the beginning about civilization and its basic, its water, shelter, and power, and these things. We've sort of optimized the culture now for innovating by optimized for developers and creativity in IT, because we're obsessed with IT in the information society. So now with open source, you can smash two libraries together in a library collider and create new software. And this is the way we build open source.
Your background really is physics. I can tell.
Yeah. But this is how we build software, and the inefficiencies are sort of off the scale. I can recall when I first started using computers, having a word processor, which is faster than the ones I use today. We've kind of lost 4 orders of magnitude of speed in the inefficiencies of layer upon layer upon layer of software and smashing together these different libraries, building on top of what we've got. Going back to the Kubernetes story about the networking in the cloud, we've reconstructed physical networking in a virtual space with broadcast domains and all that stuff, totally irrelevant technology for the space that it's in, and yet we use it because it's there and it already exists. And that ability to pre-use existing things rather than rethinking and optimizing and so on is now coming back to bite us, because the energy requirement to power all of this stuff is off the charts. It's not just blockchain, which is melting the polar ice caps. The IT industry passed the airline industry some years ago in its power consumption. And as long as that's the case, we're sort of up there in the top 10 of industries leading to climate change. So then we're right back to civilization scale, the planetary scale, shooting ourselves in the foot with this approach to our own creativity. So there are sort of moral questions involved in this as well. Are we willing to consider and reconsider the way that we build technologies and deploy them and utilize them on a global scale? And do we have a responsibility to try to refactor some of those things in more efficient ways, not just more secure ways?
Actually, it's a really amazing point. One of the things that's actually happening right now, most people are not aware of this, is when you look at edge infrastructure and the power requirements that are there, they're actually building out a feedback loop so that information from the power company based upon their spikes and other levels can be fed into these edge data centers. And what they're looking at is building a market there so that you can say, this is how much I'm willing to pay for these workloads when these power costs hit this area. And one of the things that we can do is the microservice approach. You have an infrastructure cost that is there, but it also helps you better carve out your usage of this and make a decision on it. And there's certain things where we cannot easily put a price on that, where there's still a price to be paid. Like, what do you do if there's a 911 service that's running on that edge data center? You want to make sure that always goes through, on the condition that you're not going to use so much power out of it that you're going to wipe out the infrastructure for the entire region, which is then you want, even in those scenarios, you may want to try to consider shedding load in that scenario. And that should be an extremely rare event. If we get to that level, we've messed up severely somewhere, or there's some really major disaster going on. But in general, that these type of things I think will emerge over time. And one of the things that it is something that we're going to have to get in front of because these resource constraints and resource managements are major issues, and we have to make sure that the infrastructure is there so that we can pull it in. And a really good example of that was when the power generation was first being installed in places like California. They did not have the infrastructure to actually deal with it. Smart meters they used large mainframes to do all the billing and so on. They didn't have the computation to actually crunch smart meters, and so when they had power generation, they actually would ship a list of power values that they collected to lawyers who would then manually work out the bill and then feed it back into the system. And now it's automated, but like there were serious growing pains there that we're going to experience again.
So there's a theme that I'm sort of feeling under a lot of this around how we partition complexity in systems, right? Because if you look at it, and not just partitioning complexity, but partitioning complexity in both space and time. Right, so Eli's point about scalability. The number one thing I see that kills scalability is the failure to actually cleanly partition complexity. If you build a centralized system, what you've done basically is you've taken a huge ball of complexity and placed it in one place. And at some point you exceed the critical mass of complexity in that place and your scalability breaks. And if you look at some of where we're trying to go with microservices, and to a certain extent where we're trying to go with service mesh, and I'm not sure we're successful in either, is to repartition a lot of that complexity in a way that scales better by localizing most of the complexity of the system. And this has an implication for security, because often what's involved in getting security right is being able to reason about the complexity of the thing you're looking at to decide what the correct behavior is vis-a-vis the current set of events. And so if you've got a system that's massively complex, it is virtually guaranteed you will screw that up.
I love that point. I can shoot in a quick advertisement for my book. I actually wrote a book 2 years ago called Smart Spacetime, where
we really have to talk offline.
yeah, I know. Actually, a couple of books, but this was a semi-popular one, and it's trying to introduce some of these ideas about how we need a new model of, well, space and time in the sense of not only in physics, but in the network. And the network is also a model of space-time, processes, locations, times, changes, and so on. But the thing that's new in our modern world is that we can no longer avoid doing the thing which we've tried to do in physics the whole way, which is eliminate semantics from the discussion. We only look at the quantitative and ignore the qualitative because it gets in the way of counting the quantitative. But now with smart functions and adaptability and adaptation complexity, we really can't get away with avoiding the semantics or the qualitative aspects of space and time. And this work I've done over the years on promise theory is really looking at a way to model all that and bring it into a form where we can understand these systems in a simple way and relate it to things that we do know about in physics. So like the principle of separation of scales. Like when things are weakly coupled, they're easy to partition. When things are strongly coupled, they can't be broken apart and they tend to be very fragile. And these are things, of course, feed directly into security as well, because fragile systems are obviously vulnerable in all kinds of ways. And the vulnerabilities of a system semantically often rest upon the dynamic vulnerabilities. In other words, the ability to scale in terms of resources, latency, capacity, and all of these sort of measurable things. So we first have to get our measurables right and balance all of those partitioning problems. And then we have to get the semantics right, which include the usability and the interactions with the other network, which is the people, because it's not really just tech, it's human tech systems that we're talking about, right? They are part of the network. And so all of these complexities really do come in, as you're saying, Ed. And I think the sooner we get into this idea of thinking of the total system, the human technological system, and not just the technological system, because it's hard enough already, perhaps the sooner we'll actually get to grips with some of these global scale issues.
Yeah, I think you're absolutely right. The one thing that concerns me, though, is that often, I don't think you're making this mistake, but often when I hear people talk about thinking about the entire system, they fail to actually reasonably partition complexity. And so what they're really talking about is creating essentially a singularity of complexity that cannot actually function properly. And so it's the partitioning of the complexity of the total system into manageable parts, both in space and time, which implies the ability to repartition them quickly, that ends up being sort of the crucial thing in my mind.
Yeah, and that's because of the semantics that you can separate them differently. The semantics become like sort of different vectors in a space, right? You can resolve along the security issue and the integrity issue, and there are different issues, different concerns. So the separation of concerns is connected to the separation of scales,
Yeah, pick your basis in the Hilbert space. Exactly.
Right. Yes. So we geeked out a little bit there.
Indeed, I think we may have shot a little bit over the top. Excellent. So I think we're a tiny bit over, although I did give us permission to go a tiny bit over. So I did want to sort of wrap this up really quickly. What we got here was exactly what I expected, which is no conclusions, but a lot of interesting ideas and perspectives on how to think about these problems being shaken loose. And so I would actually love to see continuations of this thought process as we go forward, because I think it does end up being sort of very critically important overall. So thank you so much, Gary, for hosting us. I think we all had rather a lot of fun, which is basically the point.
Exactly. Thanks, Ed. Thanks, everybody. Mark, Frederick, Eli, Sergio, Casey. I think I got everybody, and that was purely from memory, not looking at my notes. I just wanted to check. Vinay will be with you in about 2 seconds. Just wanted to see from the attendee pool or our guests if there are any questions for the panel. If not, we'll quickly move over to our next presentation. Katie, I'd like to ask a favor of you as our host. Could you quickly flash up the agenda slide one more time for us? There were a couple of requests in chat just to see the schedule for the rest of the day.
Yeah, let me do that real quick.
Just to give everybody a reset on where we are and where we're going. All righty, so again, running just a couple of minutes behind, but we're going to make that up by shortening up our break at 10:35. So we've got Vinay coming up from Google with his eBPF talk, and then we have Anthony with his Scaling Roblox talk coming up next. Right after that, we will still keep with our afternoon break, but we will, depending upon when we finish up with the next 2 sessions, shorten that up a little bit, and again, start our afternoon sessions at exactly 11:05 so we can keep all our presenters on time with the rest of the delegations outside of the ScaleX event. So, Katie, thanks very much. And I think at this point now, again, I want to thank our panel and get ready to toss the ball over to Vinay Benai from Google.